Lesson 70, Advanced Abstract Equations. We have done problems like this before. We're adding one additional step into these problems. These are multivariable equations where we're picking out a specific variable and solving for it and setting everything equal to that variable. The only difference in these problems and the ones that we have done before is the first step is going to be using the distributive property. Alright, so we're going to be distributing a variable before we solve for another. Alright, let's do a couple examples. The first one is this. We have x equals p times 1 over a plus m over b. Alright, in this equation we're going to solve for b. Alright, and the first step is to use the distributive property. We want to get rid of those parentheses. So we're going to distribute this p into the 1 over a and into the m over b. Alright, when we distribute that, we're going to be left with x equals p over a plus mp over b. Alright, we're solving for b. So instead of finding a common denominator and adding, we're trying to get that b separate, which means we want to get it to the point where we can factor it out. So we're going to multiply through each term by a common denominator in order to get rid of any fractions that we may have. So a common denominator in this case is ab. So we're going to multiply everything through by ab. All right, my first term is going to be abx. In the next term, the a's cancel out, and I'm left with bp. And in the next term, the b's cancel out, and I'm left with plus amp. Alright, again, we're solving for b, so we want to get b by itself. I'm going to subtract bp from both sides. So I have abx minus bp equals amp. And then just to get that b by itself, I'm going to factor out b, which leaves me with ax minus p equals amp. And finally, I want to divide by ax minus p on both sides. And that is going to be my final answer, amp over ax minus p. All right, let's look at another example. All right, in this example, again, we're going to use the distributive property first. All right, we have xp equals m times b over 1 plus c plus a over p. And in this problem, we're going to solve for c. All right, so the first thing we're going to do is distribute. We're going to distribute this m into each term. That will give me xp equals mb over 1 plus c plus am over p. All right, again, we're solving for c, so I want to set everything equal to c. I need to get rid of the fraction, so I'm going to multiply through by a common denominator. Common denominator in this case is going to be p times 1 plus c. So I'm going to multiply each term through by p times 1 plus c. If I distribute this p, I'm going to be left with p squared x times 1 plus c is equal to bmp plus am plus acm. I went ahead and distributed that through. All right, again, we're solving for c, so I want everything that has a c in it to be on one side of the equation. All right, in order to do that, I need to distribute this term also. So it'll be p squared x plus c p squared x. All right, again, we're going to get all the c terms on one side. So I'm going to subtract ACM and I'm going to subtract p squared x. All right, so I have all the c's on one side. I can factor that c out, and I'm left with p squared x minus am equals BMP plus AM plus P squared X. You can set the minus P squared X. And then divide by P squared X minus AM. And that will leave me with C equals BMP plus AM minus P squared X all over P squared X minus AM. All right, this last example I want you to go ahead and complete on your own. We have MX equals P times Z over X plus K plus 2S over Y. All right, and in this one, we are going to be solving for K. So go ahead and complete this example on your own, and we will check it in class.